we're going to look at simple interest versus compound interest. So I'm going to go through some examples. We'll just do quick ones, and then I'm going to give you something called the general formula. Actually, I lied. Maybe I'll give you the general formula first. Okay. Simple interest. Okay, so I'm going to call it SI. There's a general formula that says, I'm going to use a couple different letters. So it's common to see it like this. They'll write A is equal to P. Actually, I'm going to do it like this. P plus PRT. But I'm actually going to rename A. I'm going to call it FV. It means the future value. Okay, I find that a little bit easier. I know it's two letters, and sometimes we think of that as being two variables, but just represents one thing. We're looking at the future value. And then we have P is usually commonly known as the principal, but we can also call that the present value. It's sometimes easier to refer to it as the present value, okay? So there's two P's, so I'm just going to replace both of them with PV. R means rate, and because these variables are beside each other, it technically means multiplication. So times the rate, and then T just stands for time, okay? This is a formula that will help you calculate the future value of some investment using simple interest. The same concept, so this is in other words the general formula, and there's other versions of this general formula, but I like this one because it helps us solve something called interest really quickly too. And then there's compound interest, okay? Same idea, a lot of times I write it like this, A is equal to P plus times 1 plus R to the power of usually an N, sometimes they write a T, okay? But I'm going to do the same thing. I'm going to call the future amount, I'm going to call that the future value. We're going to call the P the present value. So again, this is one variable. And then 1 plus, now we're going to do annual, okay? Interest rates that are annual. Technically, it's a little more complex, these two calculations, if we have something called, have you guys heard about like monthly compounding or
No.
weekly? Okay, we're just going to focus on annual because this formula changes just a little. So we're going to keep it simplified to compare. Okay, so what's key here is we write these definitions down. So like FV stands for our future value, okay? PV stands for present value. So I'm half cursive, half print. R stands for rate, as in like a percentage, which you have to convert to a decimal. And T stands for time. Okay, so hopefully that makes it a little simpler. I'm going to do that exact example we talked about, and we're going to see some differences as we go through them, okay? So these general formulas are really helpful, but we're going to end up with, we're going to say the present value is, should I start with 1,000? Yeah, let's start with 1,000, okay? I'm going to start with $1,000. Actually, you know what? I like 100. It's a nice number. We're going to use 100. Present value is $100. Our rate, okay, is going to be 5%. It's a really simple one to imagine, 5%. And time, well, we're going to let that one go. We're going to build through time. So we're going to do 1 year, then we're going to do 2 years, then we're going to do 3 years. So this variable is going to change, okay? And we're going to do a little comparison of them. So the simple interest formula, or SI, says that the future value is equal to the present value plus the present value times the rate times time. Okay, so let's start off with T equaling 1. We're going to go for year 1, okay? So what we're trying to solve here is future value. We don't know what it is. What's nice about these formulas is because we've learned some algebra, if they've given us the future value, I can calculate the other variables in this equation, okay? But for now, we're going to focus on calculating future value. So FV, future value, is what we're trying to find. PV, that's our present value. Well, we have $100, okay? We're going to add, and we're going to add 100, which is, again, our PV, times our rate, 5%. We calculate by making this a decimal by putting it over 100 and then just dividing. So we get 0.05. Okay, so times 0.05. And time, we said, will be 1 year. If we do our calculation here, we get 100 plus the number 5, which means the future value after 1 year is, it's a terrible 5, but $105. That's pretty simple.
Yeah.
That one was easy. You got that when we went through it. I'm going to quickly do the compound interest. Same idea. Future value is equal to present values. Formula, the general formula is a little different, so I'll rewrite it. Okay, times time. I'm going to see how this is going to make an impact after our first year. So future value, still 100. times 1 plus the rate is 0.05 to the power of 1. Well, to the power of 1 doesn't really change anything. We just end up with 100 times 1.05. So a little bit different of an operation, but in the end, we end up at the same number. When I multiply those, you'll find that I'll get $105. So after 1 year, the compound, or after one compounding period, it's a better way to describe it, we end up with the same amount. No real difference in one compounding period. It's when we get to 2 and 3 and 4 that things start to change. Okay? So what's interesting about simple interest is we have to calculate something called the interest. We've got to calculate what the interest is each year. And it turns out interest, I, is equal to PV times R times T, which I know looks confusing, but it's actually this part of the formula. That's what that is. That's why I like using this version, is we can find I really quickly. That part of the formula when we did our calculations was $5. So this number becomes super important because for every year, so when we let's just say we went from year 0 to year 1, we went up $5, right? That is what we get every single year. Doesn't matter what's in the account, what the present values are, it doesn't change, okay? It's the original present value. So we got 5. And then simple interest, if we go from year 1 to year 2, we still get $5. And if we go to year 2 to year 3, still $5. Nothing changes. That's what simple interest is. We get an interest amount, and that's what we get every single year. It doesn't matter what's in the account, okay? Compound is more complex, okay? So because that exponent value changes, we'll see this become slightly different. So essentially what's happening is we'll draw it out. Our future value is then dependent on the new present value, which is 105. So we go 105, okay? If we're trying to calculate from year 1 to 2, because we already did year 0 to 1, right? So our new future value becomes the present value. And then we go through that same process again, 0.05, power of 1. If we multiply it, what did you tell me? I get $110.25? Okay. So if we compare $110.25 to 105, do a little subtraction, and it turns out we made $5.25. Okay. So let's get rid of that. Let's do a little side-by-side comparison here. From year 0 to year 1, we had the same amount, or the first compounding period. We went up $5. But in then year 1 to year 2, we actually went up $5.25. I mean, that's not a huge amount, but it's growing. And we're talking about your money. If you're investing, great. Might as well get more if we can. So then the question becomes, what about year 2 to year 3? Okay, well, we just take, again, our new present value, our future value, which becomes the new present value. So we calculate again and we go, what's the next year? Well, the next year would be the future value is equal to $110.25, because that's what's in the account after those 2 years, times 1 plus 0.5. Oops. I'm going to get you to help me out with the calculator here, okay? I'm going to get 110.25, and we're going to multiply by 1.05. Because, again, we're just calculating one compound period at a time.
So 115.7625.
7625. We're going to round it to 76. Which means if we do some subtraction, we do 115.76, subtract 110, and you end up with getting plus $5.51. Hey, that's a little more than that year. So every year, what we're increasing by goes up. Now, imagine we had to calculate to year 100. This process, this algorithm, is very tedious and very slow. That's why these little formulas I gave at the beginning, while they didn't seem too helpful, are super helpful, because we can just get a value for time. We just got to figure out how far down the road do we need to go. So let's do that. Let's go for 100 years. Let's slide over here. Simple interest says that the future value is equal to the present value plus the present value times the rate times the time. Our present value, we said, was 100. That's what we're starting with. Our rate was 5%. And this time is 100 years. Okay, and everything is annual, so say 100 years. So let's calculate. Our future value in 100 years becomes $100 plus 100 times 0.05 times 100. That becomes 100, that becomes 2 times 5, I believe says plus 500. You might want to double check with the calculator there. But we'd have $600. Hey, not bad. We increased a lot. I mean, 100 years is a pretty long time. We got up to $600 though, using simple interest. Let's see compound interest. Compound interest, same values. Future value is equal to the present value times 1 plus r to the power of t. Our future value is equal to, we start with 100. Our interest rate, when we make it a decimal, is 0.5, but we go to the power of 100. So this part I'll need some help with. I need 1.05 to the power of 100.
That.
Huge number. And then can you multiply that by 100? 13,150. I'm going to go double check your numbers if that's okay. Let me just do a quick one. 1.05 to the power of 100. Yeah, it looks good to me. 13,000. That is a huge difference.
Yeah.
So in real life, there really aren't many scenarios where you have simple interest. It really doesn't exist. This is what a true financial product is. They measure this way. And see how powerful compounding interest is? It's amazing. So, I mean, 100 is a long time to live, but I mean, you put it in it as a baby, put 100. But if I put in like $1,000, right? This would be a huge difference. This would be $6,000. This would be $131,000. You know, like it makes a huge difference, that compounding interest. So it's really important that we realize these general formulas are great because they can help us calculate way down the road without having to go through, which is not wrong, this tedious algorithm. We're doing 1 year by 1 year by 1 year. We can just go, okay, what year are we looking for? Let's go to year 1000, and then this would be absurd, the amount of money that you would make.
Yeah.
Okay?